Hello everyone, today we're going to explain the last part of the HCIE-Datacom LAB exam, which involves network programming automation. We'll go over the scenario description, the configurations we need to complete, and the final expected outcome when everything is running. So what about this part? Overall, it accounts for about 1/10 of our lab exam and is relatively simple. Looking at the overall exam topology, let's take a look at the full topology diagram. Previously, we explained the first part where our main task was to configure the X area. This part of the configuration covers some of the basic practical requirements found in our traditional campus networks. So, in section 4, which is about automation, the main focus is still on our X campus. What we mainly need to do is log into the terminal to perform operations. That is, we need to use this test machine as the main host for running our code to monitor our XTHD1, which is the device after stacking. This device, in other words, is the one we now need to automate for status monitoring. The way we achieve this is by writing a Python script on their terminal 01 so that we can monitor the current device. Some routine status monitoring for the XTAG one, such as its power supply fan, the LACP running on the device and its LCP status, CPU and memory utilization, as well as the OSPF neighbor status. We need to carry out a complete monitoring of it. Here, we will have some specific and detailed requirements, which we can take a look at in a moment. Ultimately, what we need is to successfully execute this code, meaning that our inspection code should run successfully, including being able to see the output information properly in Python, as well as our ability to... There needs to be a regular backup file, and in the exam setting, we also need to submit a compressed file. That means after each inspection, our code will generate a compressed package of the inspection logs, which will be reflected in our code. So, in this process, submitting the complete output results and the compressed log package we generate are our basic requirements. In other words, we've clarified the implementation requirements. In the future, when we log into the device and run Python, of course, the device will also need to be configured accordingly to respond to the commands executed by our Python scripts. All right, let's take a look at this requirement as we move on to the fourth part. Okay, so this is our overall requirement. Previously, within Campus X, we used a more traditional configuration approach, which meant entering commands directly on the devices. However, moving forward, we need to complete a basic project inspection. That means we no longer have to worry about managing everything manually on a daily basis. Here, in order to improve network efficiency and better detect faults, we need to write a script. As I mentioned earlier, we need to output some information from the devices. So we will have some command lines, such as display power, display the status of LACP, and so on. We will also write a command txt script, where we specify which commands you need to enter on the device to output this information. Later on, our script will use Python code to execute these commands in batches on our devices. On this switch, in the requirements below, we have some more detailed needs. To put it simply, between your terminal and the switch, we should use a secure management channel mode. So here we are using SSH. As for the status results, we need to analyze them. For example, if there are fans on my device, and if a fan malfunctions, for instance, if there are 2 fans inside right now, if both of them malfunction, then we need to provide a clear alert message indicating that the fan is now damaged. Also, it is required here that the monitoring commands executed in our script are exactly the ones listed above. We cannot use any others. The script must directly reflect this. So as I mentioned, we will write a dedicated txt file in the future where we will put these commands and then use Python code to call and execute them in batches, treating it as a file for Python to read. Next, as we mentioned, after a certain period of time, we need to perform a file backup. This is one of our basic requirements. We also need to complete some basic configurations on the device. Let's take a look at the final result when it runs, okay? Here, when we demonstrate this host, it's just like what you'll do in the exam room in the future. Open the exam's mobile system. So after you open its connection software, you can see the device list here. The one we're dealing with this time is this one, our T1, the aggregation computer in the building that we stacked earlier. What we're using is Terminal 1. This is a script I had already run before, but I'll clear it first and we'll run it again in a moment. So in the future, when you log into Terminal 1, our PyCharm is right on the desktop. Just click to open it. This is the format of the final compressed log package we generate. After you open it here, you can create a new file and start writing your script. To save time, I've already written this script in advance. Once you finish writing, you can click here to run it, though it may run a bit slowly. Let's click here. Just now I cleared it. Let me clear it again. All right, now let's click run here. There's a warning here, but you don't need to pay much attention to it. It's just a distinction about the execution bitness. We're using a 32-bit version here, so there's no need to worry. It doesn't affect the final output in the command line. This is just related to some settings when we installed the terminal. Its execution will take relatively longer. Here, I want to emphasize a basic point. In the future, before you run a Python script, you should pay attention to this. As you can see here, the fan information output has already appeared. It will execute step by step, and after each step, it will output information in batches. Let's wait a moment. Here we can check the power information. As long as you successfully execute this command, you can view the power information. Whether it is output or not depends on certain settings related to this information in our current rack. During the exam, as long as these commands are executed successfully, that's enough. For example, here you can see the CPU usage history. If we scroll down, it will continue to output other information. For instance, here we can take a look at the memory, and in a moment there will be some more output. We can wait a bit. All right, let's pull it up a little higher. Okay. During the output process here, this is the information about LACP that we mentioned earlier. That is, on our device. Remember, we previously set up link aggregation in the X campus, which was part of Section 1. Here, by using automated script execution on the device, we can see this information. The current link aggregation status on the device. This is really convenient. Meanwhile, finally, we still have one more thing, which is the OSPF neighbor status. Once all this information has been output, our script is basically done. At this point, we'll start to do some further operations here. Now, regarding our file configuration backup, there's one thing I need to emphasize to everyone. For Section 4, during the exam, you can actually type it in advance. That is, you can log into the terminal and run this script first. Whether you do this depends on how you plan your exam, but before we actually run this Python script, you need to make sure that within the X campus, your terminal 1, that is our device here, is ready. All right, let me scroll up a bit. Regarding the overall topology we just discussed, for your Python script to run successfully, there's a fundamental prerequisite. Your terminal 1 must have already completed authentication and obtained an address. Just like we did earlier in step 31. Inside the X campus, didn't we set up some access control here, including configuring an address pool, right? So our PC1 needs to complete access control, meaning it must authenticate and obtain an address, and it also needs to be able to communicate with XTAG1. Only then can it successfully execute the Python script. So inside the X campus, your wired terminal won't be able to successfully run Python until it has completed authentication and obtained an address. Of course, you can type out the code in advance, but before you actually execute it, you must have already established successful communication with the host. So make sure you've completed all the previous steps first, okay? If your device hasn't even obtained an address, hasn't passed access authentication, hasn't been assigned the corresponding address, and can't communicate with the host, then it simply won't work. If there's no communication, you won't be able to establish the corresponding netconf or SSH connections with it. In that case, your configuration as a whole will fail. All right, that's the basic explanation above. Now, this result has already finished running. During the exam process, we'll have you submit these accordingly. That is, you'll copy it. Please take some screenshots, then copy the results and submit them together with your code. That's all you need to do. So, what we just saw here is also the basic situation on our current exam machine. So this is what we've covered in this section of Python. So the command we just talked about can be opened up for everyone to see. It shows some data inside the fan and how to read it. Here we have a dedicated file for this purpose, which we usually place in a specific directory to make it easier to call. What's being executed here is a file we've just generated. By default, we save it as something like vrp.cfg.vip, which is a compressed file, a backup of the device's configuration. And right now we are running this Python code for data. In this process, the code will show, for example, when we need to perform batch backups of device configurations, we use this corresponding set of code. For instance, if there is a problem with the fan, here we check all the fans, and if any issues are found, we output an error. Besides that, we need to call the commander's TST here to execute our current command, and the file we are calling is this one. All of the content presented here fully meets the necessary requirements for running Python scripts in our current exam environment. Therefore, when you see this page, it indicates that for this particular section, you have already successfully earned your points. All right, that's it for today's Python recording. As for this code, we'll send it to you when it's time for you to type it out. Just follow our standard code format when you write it. It's not too much, just about 100 lines or so. All right, that's it for today's video recording. We'll see you next time in another video. If you want to inquire about our courses or get materials, you can leave a comment below my video. I'll reply to everyone as soon as I see it. Goodbye, everyone.